Asynchronous data flow is one of the most challenging concepts to learn, but also one of the most important when working with Flutter and Firebase. When you listen to a user's authentication state, or if you read data from the database, it will be returned in either the form of a future or a stream. The main conceptual difference between the two is that a future is just a single value that resolves once. So a request is made, it returns some data, and then it's done. A stream, on the other hand, can be long-lived. For example, we listen to the stream and it might emit multiple values over the course of time. And that's a really awesome thing to have in a reactive framework like Flutter, because we can listen to a stream and then have the UI react when the data changes. But streams are a little more difficult to work with because we need to be careful about how we manage streams, because if we listen to one and just let it sit in the background, it could cause a memory leak. Now that sounds like a lot of work, but luckily Flutter has some built-in mechanisms that make this really easy. But before we get to that point, I want to show you how to manage your streams manually so you know how the API looks, but this probably isn't how you want to do it in the real world. So what we're displaying here is a user profile that contains a photo URL as well as the username. And this data is all retrieved remotely from Firestore. Now taking a look at this code, you'll see here that we first have a stateful widget. And then if we go into the state, we have an instance of Firestore. And then we have a property for the data and also a property for the subscription so we can manage it. We can make a reference to this document in Firestore by calling collection users with the document ID, and then listen to the snapshots which return a stream. Then whenever that stream emits some new data, we'll go ahead and call setState and set that as the data property on this widget. That'll ensure that this widget always displays the most recent data, but we also need to manage the subscription if the user navigates away from it, so we'll go ahead and call subscription cancel in the dispose lifecycle hook. Now moving down into the build method, we'll check to see if the data is not null. And if it's not, then we'll go ahead and display the UI that we want to show here with the profile URL and the username. And we can access that data on the map using brackets notation and then a string with the name of the key. Now accessing data with bracket notation gets really tedious and really hard to maintain as your application grows. Later in the course, we're going to look at how to deserialize this data into an actual Dart class, but that's not something that we need to worry about right this second. So this approach works perfectly fine, and you can see that our data stays up to date if we change it in Firestore on the backend. But the problem is that we have a lot of boilerplate code here, and it's also going to be more error prone because we're managing that subscription manually. Flutter has a built-in widget called a stream builder, and there's also one called a future builder as well. And they'll do many of the things that we just did in the stateful widget automatically. For example, they will automatically listen to the stream so we don't have to call listen on anything, and they will also dispose of the stream when the widget is destroyed or removed from the widget tree. We'll go ahead and use the VS Code refactor tool to move some of this UI into a new stateless widget. The stream builder will automatically re-render the UI whenever the stream emits a new value. So there's no need for a stateful widget, which eliminates some of the boilerplate. So we can again use the refactor tool in VS Code to simply wrap our UI in a stream builder. And then we'll pass it the same stream that we listened to in the stateful widget, which is the reference to the Firestore collection with the document ID. And we can also pass in a generic type of document snapshot here so we can use IntelliSense when the value is emitted from the stream. Now we have the exact same functionality that we had in the previous stateful widget, just with less code and greater reliability. Now, while we're looking at the stream builder, I'd also like to point out that there is a future builder, which allows you to resolve a future instead of a stream. Now, once a future is resolved, it's not going to emit any changes. So it's good when you navigate to a new screen and need to preload some data into that screen, but don't need to list the changes in the future. And you can return your data from Firestore as a future instead of a stream by calling get instead of snapshots. And yet another benefit of the stream builder approach is that if you want to refactor from a stream to a future or vice versa, it just takes a few minor changes as opposed to completely rewriting the code in the lifecycle hooks of the stateful widget. Now, believe it or not, there's actually a better way to do this, which we're going to look at in the next video using a library called Provider. Stream Builder is very powerful, but what if we wanted to share a stream across multiple widgets that might be nested at deeper levels in the widget tree? Or maybe our UI depends on multiple streams at the same time. In the next video, we'll look at how Provider solves some of those problems for us.